Quadratic equations. Quadratic equation is the equation having maximum index of variable 2. For example, x square plus 5x minus 300 equals to 0. Quadratic polynomial. The general form of a quadratic polynomial is ax square plus bx plus c, where a, b and c are real numbers and a does not equal to 0. For example, polynomial for variable x equals to x square plus 2x plus 5. Here a equals to 1, b equals to 2 and c equals to 5. P of x equals to x square minus 7, where a equals to 1, b equals to 0 and c equals to minus 7. P of x equals to x square plus 5x plus 3, where a equals to 1, b equals to 5 and c equals to 3, etc. Zeros of a quadratic polynomial or roots of the quadratic equation. The values of x for which the value of a given quadratic polynomial becomes 0 are called the zeros of the quadratic polynomial. Let us now consider a polynomial. P of x equals to x square plus 5x plus 6. Here we table some real numbers for x and the respective values of P of x. We find that for x is equal to minus 2 and x equals to minus 3, the value of the polynomial for variable x is 0. So, minus 2 and minus 3 are called zeros of the quadratic polynomial. Every quadratic polynomial has at most 2 zeros. Standard form of the quadratic equation. The equation of the form ax square plus bx plus c equals to 0, where a, b, c are real numbers and a does not equal to 0 and x is a variable is called quadratic equation. Here a is called the quadratic coefficient, b is the linear coefficient and c is the constant term. For example, y square minus 11y minus 4 is equal to 0. In the equation ax square plus bx plus c equals to 0, if b equals to 0, then the equation becomes ax square plus c equals to 0, which is also a quadratic equation. For example, 6x square plus 12 is equal to 0. Similarly, if c equals to 0, then ax square plus bx equals to 0, which is a quadratic equation. For example, 2p square minus 4p is equal to 0. If b equals to 0 and c also equals to 0, then ax square equals to 0, which is also quadratic equation. For example, 5x square is equal to 0. But if highest index of variable x is more than 2 or less than 2, then it is not a quadratic equation. For example, y raised to the power 4 minus 4y raised to the power 3 plus 3 is equal to 0. Roots of the quadratic equation. The values of the variable which satisfy the given quadratic equation are called the roots of the quadratic equation. Example, x square plus 3x minus 4 equals to 0. Take some real numbers for x as 1, minus 2, minus 3 and see whether the equation is satisfied or not. Substituting x equals to 1. In equation, x square plus 3x minus 4 is equal to 0. Left hand side equals to 1 square plus 3 into 1 minus 4 equals to 0. As left hand side equals to right hand side, therefore x equals to 1 is the root of the given quadratic equation. Substituting x equals to minus 2. In equation, x square plus 3x minus 4 is equal to 0. Left hand side equals to minus 2 square plus 3 into minus 2 minus 4 equals to negative 6. As left hand side does not equal to right hand side, therefore x equals to minus 2 is not the root of the given quadratic equation. Substituting x equals to minus 3. In equation, x square plus 3x minus 4 is equal to 0. Left hand side equals to minus 3 square plus 3 into minus 3 minus 4 equals to minus 4. As left hand side does not equal to right hand side, therefore x equals to minus 3 is not the root of the given quadratic equation. Example, if one root of the quadratic equation x square minus 11x plus k equals to 0 is 9, then find the value of k. As x equals to 9 is the root of the given equation, so it satisfies the given equation. Therefore, 9 square minus 11 multiplied by 9 plus k is equal to 0. That gives 81 minus 99 plus k is equal to 0, or minus 18 plus k is equal to 0. Therefore, the values of k for the given equation is 18. Methods of solving quadratic equation. Following are the methods for solving quadratic equations. First, factorization method. Second, completing square method. And formula method. 1. Factorization method. If the product of two numbers is 0, then at least one of them must be 0. Steps. First step. Write the given equation in the form ax square plus bx plus c equals to 0. Second step. Find the two linear factors of the left-hand side of the equation. Third step. Equate each linear factor to 0. Example. Solve the quadratic equation x square plus 10x plus 24 equals to 0 by factorization method. First step, that is, writing the given equation in the form ax square plus bx plus c equals to 0. For this, 10x will be split into 6x plus 4x, which sum up to 10x, and product of 6 and 4 gives 24. Regrouping the components, we get thus, x plus 4 and x plus 6 are the two linear factors. Third step, that is, equating each linear factor to 0. This gives x is equal to minus 4 or minus 6. Therefore, minus 4 and minus 6 are the roots of the given equation. 2. Completing square method. Some quadratic expressions cannot be factorized easily. For example, x square plus 6x minus 2 equals to 0. For solving quadratic equations involving such expressions, we use completing square method. That is, x plus a whole square equals to x square plus 2ax plus a square. Here, the third term, a square equals to half of the coefficient of x whole square. Steps of solving quadratic equation by completing square method. First step, transpose the constant term to right hand side and divide both sides by the coefficient of x square. For example, consider the equation x square plus 8x plus 9 equals to 0. Taking the constant term, that is 9, to right hand side, x square plus 8x is equal to negative 9. Equation 1. As coefficient of x square in this equation is 1, dividing the equation by 1 does not change it. Second step, find the suitable square term which makes the expression on left hand side a perfect square. That is, third term equals to half of the coefficient of x whole square. As coefficient of x in this equation is 8, we get half of 8 whole square equals to 16. Adding 16 to both the sides of equation 1, we get x square plus 8x plus 16 equals to minus 9 plus 16. Equation 2. X plus 4 whole square is equal to 7. Equation 3. Third step, find the square root of both sides and thereby find the roots of the equation. That is, x plus 4 whole square is equal to 7. Taking square root, we get x is equal to minus 4 plus minus root 7. Therefore, minus 4 plus root 7 and minus 4 minus root 7 are the roots of the given equation. Example, solve the quadratic equation m square minus 3m minus 1 equals to 0 by the method of completing square. M square minus 3m minus 1 is equal to 0. Taking the constant term to right hand side, we get m square minus 3m is equal to 1. Equation 1. As third term equals to half of the coefficient of m whole square, we get equals to 9 by 4. Adding 9 by 4 to both the sides of equation 1, we get m square minus 3m plus 9 by 4 is equal to 1 plus 9 by 4. minus 3 by 2 whole square is equal to 4 plus 9 by 4 is equal to 13 by 4. Equation 2. Taking square root of this equation, we get equation 3, or m minus 3 by 2 is equal to plus minus root 13 by 2. Thus, m is equal to 3 by 2 plus root 13 by 2, or m is equal to 3 by 2 minus root 13 by 2. Therefore, m is equal to 3 plus root 13 upon 2, or m is equal to 3 minus root 13 upon 2. 3. Formula method. Derivation. The general form of the quadratic equation is ax square plus bx plus c equals to 0, where a does not equal to 0. Dividing the equation by a, we get x square plus b upon ax plus c upon a equals 0, or x square plus b upon ax equals minus c upon a. As third term equals to half of coefficient of x whole square equals to b square upon 4a square. Adding b square upon 4a square to both sides of equation 1, x square plus b upon ax plus b square upon 4a square is equal to b square upon 4a square minus c upon a. Or x square plus 2 into x into b upon 2a plus b upon 2a whole square is equal to b square minus 4ac upon 4a square. Equating the left hand side of the equation to a square plus 2ab plus b square is equal to a plus b whole square, we get x plus b upon 2a whole square is equal to root b square minus 4ac upon 2a whole square. That is minus b plus root b square minus 4ac upon 2a and minus b minus root b square minus 4ac upon 2a are the roots of the quadratic equation. Ax square plus bx plus c equals to 0. Here x equals to minus b plus minus root b square minus 4ac upon 2a is referred as the quadratic formula given by an Indian mathematician, Sridharacharya, around 1025 AD and hence also known as Sridharacharya formula. Example: solve the equation x square plus x minus 1 upon 3 equals to 0 by formula method. X square plus x minus 1 upon 3 is equal to 0. Can be written as 3x square plus x minus 1 upon 3 is equal to 0. Or 3x square plus x minus 1 is equal to 0. Comparing with ax square plus bx plus c equals to 0, we find a is equal to 3, b is equal to 1 and c is equal to minus 1. Therefore, b square minus 4ac is equal to 1 whole square minus 4 into 3 into minus 1. Is equal to 13. Putting the values of a, b and c in the formula, x is equal to minus b plus minus root b square minus 4ac upon 2a. We get that is minus 1 plus minus root 13 upon 6. Therefore, minus 1 plus root 13 upon 6 and minus 1 minus root 13 upon 6 are the roots of the given equation. Nature of roots of a quadratic equation. We know that there are two roots for a quadratic equation: ax square plus bx plus c equals 0, where a does not equal to 0. Let alpha and beta be the two roots. Then the roots of the equation are alpha equals to minus b plus square root of b square minus 4ac upon 2a. Beta equals to minus b minus square root of b square minus 4ac upon 2a. Here, b square minus 4ac is called discriminant of the quadratic equation and it is denoted by delta. If b square minus 4ac is greater than 0, then square root of b square minus 4ac is real. Therefore, in this case, the roots of the equation are real and unequal. If b square minus 4ac equals to 0, then square root of b square minus 4ac equals to 0. Therefore, in this case, the roots of the equation are real and equal. That is, the equation has repeated roots. If b square minus 4ac is smaller than 0, then square root of b square minus 4ac is not a real number. Therefore, in this case, the equation does not have real roots. Note, if b square minus 4ac is greater than 0 and b square minus 4ac is not a perfect square, then the roots of the quadratic equation are irrational and occur in pair. Following table gives the summary of these results. Example: determine the nature of roots from their discriminants. 1. X square minus 2x plus 9 upon 4 equals to 0. Or, this gives 4x square minus 8x plus 9 is equal to 0. Comparing this equation with ax square plus bx plus c is equal to 0, we find that a equals to 4, b equals to minus 8 and c equals to 9. As delta or discriminant of a quadratic equation is given by b square minus 4ac, putting the values we get that is equals to 64 minus 144. Therefore, delta equals to minus 80. Here, as delta is smaller than 0, so roots of the quadratic equation are not real. 2. X square minus 8x plus 16 is equal to 0. Here, a is equal to 1, b is equal to minus 8 and c is equal to 16. As delta is equal to b square minus 4ac, putting the values we get is equal to 64 minus 64 is equal to 0. So, roots of this quadratic equation are real and equal. 3. 2x square minus 3x minus 4 is equal to 0. Here, a is equal to 2, b is equal to minus 3 and c is equal to minus 4. As delta is equal to b square minus 4ac, putting the values we get is equal to 9 plus 32 is equal to 41. As delta is greater than 0, hence roots of this quadratic equation are real and unequal. Relation between the roots and coefficients. The roots of the quadratic equation ax square plus bx plus c equals to 0 are alpha equals to minus b plus square root of b square minus 4ac upon 2a and beta equals to minus b minus square root of b square minus 4ac upon 2a. Then the sum of alpha and beta is given by minus b upon a and product of alpha and beta is given by c upon a. Derivation. Adding the values of alpha and beta, we get alpha plus beta is equal to minus b plus root b square minus 4ac plus minus b minus root b square minus 4ac upon 2a. That equals to minus 2b upon 2a or minus b upon a. Thus, sum of the roots is given by alpha plus beta is equal to minus b upon a, that is, minus coefficient of x upon coefficient of x square. Derivation. Multiplying the values of alpha and beta, we get alpha into beta is equal to minus b plus root b square minus 4ac upon 2a into minus b minus root b square minus 4ac upon 2a. This gives minus b plus root b square minus 4ac minus b minus root b square minus 4ac upon 4a square or minus b square minus root b square minus 4ac upon 4a square. Or b square minus b square plus 4ac upon 4a square is equal to 4ac upon 4a square is equal to c upon a. Thus, product of roots, that is, alpha into beta is given by c upon a, that is, constant term upon coefficient of x square. Example. Find k if roots of the equation x square plus kx plus 48 equals to 0 are in the ratio 3:4. Given quadratic equation is x square plus kx plus 48 equals to 0. The roots of the quadratic equation are in the ratio m, that equals to 3:4 as given. Let alpha equals to 3m and beta equals to 4m. We have alpha into beta is equal to c upon a. Putting the values of c and a from the equation, we get alpha into beta is equal to 48. Thus, 3m into 4m is equal to 48. Or 12m square is equal to 48. Or m square is equal to 4. Therefore, m is equal to plus minus 2. As we know, alpha plus beta is equal to minus b upon a. Putting the values of b and a from the equation, we get alpha plus beta is equal to minus k upon 1. Alpha plus beta equals to minus k. Thus, 3m plus 4m is equal to minus k. Or 7m is equal to minus k. Or k is equal to plus minus 14. Thus, the value of k for the given quadratic equation is plus minus 14. To form quadratic equation, if its roots are given. If alpha and beta are the roots of the quadratic equation in variable x, then the two values for x are alpha and beta. Or x minus alpha is equal to 0 and x minus beta is equal to 0. Or x minus alpha into x minus beta is equal to 0. Or x square minus alpha plus beta x plus alpha beta is equal to 0. The respective quadratic equation will be given by x square minus sum of the roots into x plus product of the roots is equal to 0. Example: if the roots of the quadratic equation are 6 and 7, then find the quadratic equation. Let alpha equals to 6 and beta equals to 7. Then alpha plus beta is equal to 6 plus 7 is equal to 13. And alpha into beta is equal to 6 into 7 is equal to 42. As a quadratic equation is given by x square minus alpha plus beta x plus alpha beta is equal to 0. Thus, the required equation is x square minus 13x plus 42 equals to 0. Word problems on quadratic equation. Quadratic equations are used to solve problems in our daily life. Method of solving problems. Step 1. Convert the problems into symbolic language, that is, mathematical equation. Step 2. Solve the quadratic equation thus formed. Step 3. interpreting the solutions of the equation into verbal language. Example: the difference between the length and breadth of a rectangular playground is 1 meter. The area of the ground is 420 square meter. Find the cost to fence the ground at the rate of Rs 100 per meter. Solution: let the length of the ground be x meter. Then the breadth of the ground is x minus 1 meter. Area of a rectangle equals to length into breadth. Therefore, 420 equals to x into x minus 1. Therefore, x square minus x minus 420 equals to 0. Therefore, x square minus 21x plus 20x minus 420 equals to 0. Therefore, x into x minus 21 plus 20 into x minus 21 equals to 0. Therefore, x minus 21 into x plus 20 equals to 0. Therefore, x minus 21 equals to 0 or x plus 20 equals to 0. Therefore, x equals to 21 or x equals to minus 20. As the length cannot be negative, x equals to minus 20 is unacceptable. Therefore, length equals to x equals to 21. Therefore, breadth equals to x minus 1 equals to 21 minus 1 equals to 20. Therefore, the length and breadth of the ground are 21 meter and 20 meter respectively. Perimeter of the playground equals to 2 into length plus breadth equals to 2 into 21 plus 20 equals to 2 into 41. Therefore, perimeter of the playground equals to 82 meters. Cost to fence the ground equals to perimeter of the playground into cost per meter equals to 82 into 100 equals to 8,200. Therefore, the cost to fence the playground is Rs 8,200.